Alright, so this problem is on your homework. A torus is formed by revolving a region about the circle x squared plus y squared equals 25 and the line x equals 7. Alright, and so we have this figure here being revolved around this line. And so if you do that, if you go all the way around, this is going to be, a solid tubular figure, I guess you could think of it. This problem causes a donut-shaped solid. Find the volume of the donut-shaped solid. I guess a cross-section will kind of look like a donut. The integral given below represents the area of a semicircle. So this right here, if we just use geometry, so like if you say, okay, we've got a radius of 5, and so say we want to know this area, that's pi r squared. So pi times the radius squared would give you the area of this entire figure. This, it says, represents the area of the semicircle. So this integral here is just going to be this top area. So pi r squared, I said, was 25, 25 pi. And then half of that would be 25 over 2. This right here, 25 over 2 times pi. So if you wanted to know the area of the semicircle, or what this integral is equal to, it's equal to 25 over 2 times pi. That's important on down in the problem. Okay, so now if we want to find the volume, remember usually we have, let's see, if we use the shell method, the formula is 2 pi, even though we have a 4 pi here, it's 2 pi times the integral from negative 5 to 5 times this right here will give you the radius at any point of x. Even if you're over here in the negatives, you'll still get the radius out of this formula. And then this right here, the height is going to depend on this right here. Okay? Now, since this height would just give us from here to here, if we revolve that figure, it would be cut in half. It wouldn't be the entire figure. So you need 2 times the entire figure. That's where they got the 4 pi from. There would usually be a 2 pi out here, but again, with this formula, the height is this right here, which is the square root of 25 minus x squared. That's the square root of 25 minus x squared. So 2 times that would give us this height and this height. So we have to double the volume we would usually get if we want the volume of the entire figure. Alright, and so then what they did, they distributed, they multiplied this square root times the two things inside the parentheses, and that gives you two integrals. It gives you this integral here and this integral here. Alright, the first integral we don't know how to do because it's 25 minus x squared. If you let what's under the radical be your u, you don't have your du. So that's where this up here where they told us the integral given below represents the area of a semicircle. So this right here will equal the area of a semicircle. And I told you a second ago the area of this semicircle was 25 over 2 times pi. So that's where this comes in. Instead of having to evaluate the integral, we know that the integral represents the area of the semicircle. We can find the area of the semicircle using geometry. And so then you just plug that in right here. So this 7 right here that was on the outside, they moved it in front, so you have 28 pi times 25 over 2 pi plus, alright, and when you multiply this radical times this x, you get this other integral here. This you can do. Let what's under your radical be your u. Your du is negative 2x, and so the x is on the outside. Alright, so just integrate that like we normally would. Then you're going to get 350 pi squared plus this, which I believe is just going to cancel out. You're going to get a 0 when you plug in a 5. You can get a 0 when you plug in a negative 5. So you get nothing here. So the answer for this problem was 350 pi squared.